Hello students, welcome to RK's online classes. This is the problem sent by student as a part of our doubts clearing session. That is, a particle of mass m, charge q has initial velocity v bar is equal to v naught j cap, that is along positive y direction. If an electric field vector E bar is equal to E naught I cap. That means the electric field is along x direction. The magnetic field is along x direction. B is equal to B naught I cap. Act on the particle. So its speed will double after time t. That means when a charged particle enters electromagnetic field, electric field as well as magnetic field, okay, you have to find the speed after what time the speed becomes double. Okay, so let me explain the basic concept behind this problem. So we know that the force experienced by a charged particle in electromagnetic field is given by F is equal to Q into E plus V cross B, where E is electric field, V is velocity vector, B is magnetic induction field, and here this F is called Lorentz force. So when electric field is 0, let us say only magnetic field acts on a charged particle, then force is equal to BQV sin theta. When theta is equal to 0 or 180, force 0, the path followed by charged particle is a straight line. So it means without any deflection, the charge flows. Okay. So when theta is 0 or 180, the path followed is a straight line path. So when a charged particle enters perpendicular to magnetic field, that is theta is 90 degrees. Then the force is F is equal to Q into V cross B, and the force is perpendicular to velocity. Important thing is force is perpendicular to velocity and acceleration is perpendicular to velocity. Whenever the acceleration is perpendicular to velocity, the path is circular. So, and one important point you have to note down here is when a charged particle enters perpendicular to the magnetic field, the magnitude of velocity remains constant, the kinetic energy constant, the magnitude of momentum constant, and what is going to change? So the magnetic field changes only direction of velocity, because according to work energy theorem, F dot V is 0, because force and velocity are perpendicular, dot product of force and velocity is 0. Okay. So these are the very, very important points you can note down. So when a charge enters obliquely, that is theta is not equal to 0, not equal to 180, not equal to 90. Let us say theta 45. Then the force is BQV sin theta. Then the velocity has a horizontal component V cos theta in the direction of magnetic field. So the path followed by the charged particle is helix. Okay, helix with uniform pitch. Because of this V cos theta component. Okay, if horizontal component is not there, it follows circular path. So when a charge enters in electric and magnetic field, both are there, but electric field is parallel to magnetic field, both are parallel. When a charge enters perpendicular to magnetic field, okay, it follows helical path, but increasing pitch, but the pitch is increasing. It follows helical path with increasing pitch. You can see in this small video. Okay. So when electric and magnetic fields are parallel, so that electric field accelerates the charged particle. So take the another case where electric field is perpendicular to magnetic field. Let us say initial velocity 0. Then the path followed is cycloid. The path followed of the particle is cycloid. You can see the video diagram. Okay. The path followed by a charged particle in electric and magnetic field where they are perpendicular to each other. The path followed is cycloid. So let me summarize all the results. If a charged particle enters only electric field, that is parallel to electric field, the path is straight line. Okay? The path is straight line. Either parallel or anti-parallel, the path followed is straight line. Other than 0 and 180, the path is parabola. Only electric field. Okay? There are only two cases, either straight line or parabola when a charge enters only electric field. But only magnetic field, if you take only magnetic field, parallel or anti-parallel, the path followed is straight line. When a charge enters perpendicular to magnetic field, that theta is 90, the path is circular. Path. Other than these three, 0, 180, 90, oblique, which are okay, the path followed is helical with uniform pitch. Helix with uniform pitch. Okay. So, next, if charged particle enters into electric and magnetic field, okay, in a space where electric field and magnetic field are parallel, then let us say enters perpendicular to magnetic field, then the path followed is helix with increasing pitch, okay, because that electric field goes on accelerate the charged particle, the magnitude of velocity changes. Okay. The last one, when electric field is perpendicular to magnetic field, let us say V is equal to 0, the path followed is cycloid path. Okay. So just remember all these cases. So finally, let us solve the given problem. That is, when a particle enters in electric and magnetic field, where electric field and magnetic field in the same direction, but velocity vector is perpendicular to the magnetic field. So the path is helix with increasing pitch. Already we studied this. Okay. So the initial velocity is along y direction. Just write this one. Okay. So magnetic field doesn't change magnitude of velocity because magnetic force always acts perpendicular, velocity doesn't change. So there is a change in the velocity along x direction. Vx is equal to V is equal to u plus at, where a is eq by m. So electric force by mass acceleration. Then v square is equal to v naught square plus eq by m t square. But what is the question? So you have to find t when its magnitude of speed is doubled. In place of v, substitute 2v naught. Okay, 2v naught, and simplify, you will get the time after which the speed becomes double. So that is t is equal to root 3 mv naught by eq. So that is the answer is 3. Please subscribe for more videos. For any doubts, please WhatsApp to my number 98491 38961. Thank you.